Hello, my name is Mukhridz Shah, and today I would like to present about my presentation topic, radiation shielding materials in space. Okay, why first the introduction? Why is material selection important for an engineering design? Okay, first, it impacts the performance, reliability, and cost effectiveness of a product or structure. The selection process involves considering various factors to ensure that the chosen materials meet the specific requirements of the intended application. These factors include the performance and functionality, durability, reliability, cost, manufacturability, environmental impact, and regulatory compliance. Okay, from the design to manufacturing, choosing the right materials ensures the highest possible standard for the finished product. This is a consideration that should be taken into account throughout the entire process from the initial planning stages to the delivery of the final product. Okay, next, radiation shielding materials in space. Okay, in space, uh, exposure to various forms of radiation are common and is a significant concern for both crewed and uncrewed missions. One of the biggest challenges of the human spaceship in deep space is a harmful space radiation environment. Space radiation includes solar radiation and galactic cosmic rays. Uh, if you look at the example on figure 2, you can see a type of cosmic radiation that produce cosmic radiation are produced by the stars. So they are the one that cause solar radiation. Okay, spacecraft and its occupants require protective gears to protect them from exposed space radiations. This includes like the astronaut spacesuit and the protective layer of the spacecraft to protect them from space radiations. Okay, designing effective radiation shielding materials is crucial to ensure the safety of astronauts and the integrity of sensitive equipments. Okay, here are some of the common major space environment hazards, such as radiation damage, degradation of surface and electronics, spacecraft components, also can become radioactive, and many more. Okay, the materials used for the space shielding. Okay, we can use low Z materials because as it has low density of neutrons and highest density of electrons per atom. Hydrogen is the best material for shielding against space radiation as it has the highest density of electrons per nucleon and no neutrons. However, it is as a material, it is unstable. Therefore, the best alternative will to be any hydrogenous materials such as structurally stable polymers. Materials such as aluminum, Kevlar, polyethylene, many more have been investigated in the past. However, the best radiation shielding material truly depends on the radiation environment. And figure 4 here shows the example of layered Z-grade metal materials. Okay, CubeSat electronics circuits, they use sorry, they use layers of metal materials in the Z shielding method. Okay, high density metals such as tantalum or tungsten is coated into thin aluminum sheet in precise ratios and thickness. The combined sheet is then formed into standardized enclosures compatible with the CubeSat design and performance specifications. Okay, figure 5 here shows the tantalum or tungsten coated into thin aluminum sheet. They cover the CubeSat structure to prevent it from damaging in outer space. It also benefits them as it extends the effective life of the typical CubeSat mission. Okay, now we will talk about satellite construction. Satellites are designed to withstand the harsh conditions of space, including exposure to space radiation. Space radiation primarily includes high energy particles from the sun, solar radiation, and cosmic rays from outside of our solar system. Satellites are constructed using a variety of materials to meet the specific requirements of their mission and the challenging conditions of space. Satellites need to be lightweight yet strong enough to withstand the forces of launch and the extreme temperatures and vacuum of space. Light but sturdy materials such as aluminum alloys, titanium, and composites are commonly used for the satellite structure. Satellites use a honeycomb sandwich panel composite for the mainframe module. The panel is made by sandwiching a low density hexagonal core made up of either aluminium or Kevlar or Nomex between two stiff outer skins made of CFRP laminate or aluminium alloy. Okay, here's an example of the panel of aluminium and CFRP laminate sandwiched together, as you can see from the figure 7 here. Okay, satellites also use multi-layer insulation or blankets, or known as MLI blankets, used as thermal control materials to protect sensitive components of their satellites from damaging in outer space. Heat pipes and radiators made of materials like copper and aluminium all are also used to dissipate excess heat generated by onboard electronics. Okay, for the conclusion, we need to choose the right materials for radiation shielding in space, as it is a crucial aspect because it could mean life or death in certain situations or damage of the expensive space shuttle objects and equipments. Okay, factors to consider during material selection are resistance against radiation, the weight, durability, manufacturability, and cost effectiveness. To summarize, radiation shielding is essential for protecting both human occupants and sensitive equipment from the adverse effects of space radiation, contributing to the success, safety, and longevity of space missions. And that's all from me. Thank you for watching.